On this channel, you're going to see more and more science and technology videos. More and more science, more and more technology. You're going to see for science, physics, you're going to see biology videos, and you're going to see chemistry videos. That's mostly on the science part, but I might also be looking at new science such as nanotechnology, biotechnology, and stuff. But on the technology side, mostly productivity applications, such as the one I'm using now, which is basically Notability, which helps me to do all this writing. And I'm just using my iPad screencast, just recording the screen of the iPad to do this. Then you'll see a lot of Bitcoin talk here, because I think that's a new technology which people are not really catching up to fast enough. It's a technology that's moving very fast, but it's also a technology that people are not really paying attention to as much as I would like them to. So in this video, I just want to look at a few equations, a few physics equations. And the first one on electricity and circuits is I is Q over T. If you do a little triangle using I is Q over T, so I is Q over T, then you can get the equation Q equals I times T, which is IT, and T is equal to Q divided by I. And I being current, T being the time, and Q being the charge. So we know that when a charge flows through a conductor, an electric current is produced, and the current is the rate at which the charge is moving. Right, the next one is P equals VI. So again, you can do a little triangle for this one and do P equals IV, which basically means that I is P over V and V is P over I, where P in this case is the power, so P is the power, and I is the current, as in the previous equation, and V is voltage or potential difference. Okay. The next one is I is V over R. So again, we can do a little triangle to make it easy to remember. It's V over R. So you take the V and the R, V over R, because you're dividing, is I, which means that V equals I times R, and R equals V divided by I. So R in this case is resistance. We've already looked at what V and I are in the previous two equations. Then heat loss is I squared R. So heat loss is I squared times R, which means just the current squared times R. Okay, but if you wanted to substitute for I, and we know that from this equation, I is V over R. So you can say I is V over R squared times R. Gives you V squared over R squared times R. Then you cancel the one R and you remain with V squared over R. So this is also equal to V squared over R. This is the equation. This next one here. The total resistance for resistors in a series connection. And let's write series here. Is the sum of the individual resistances. So R1 plus R2 plus R3. But if they are in parallel, like here, then 1 over the total resistance equals 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3, and so on, depending on how many they are. So that's a little bit of electricity and circuits. In dynamics, we have F equals ma, where F is the force, m is the mass of the object, and a is acceleration. Okay, next one, P is momentum. So momentum is mass times velocity. V is the velocity or speed in a certain direction. And then we have P, F equals delta P over T. And delta P is just the change in momentum. So if delta P is a change in momentum is actually mv minus mu, because mv is the initial momentum, p initial minus p final. In fact, it's the other way. V is the final and u is the initial. So it's like that. Okay, so we can take F equals delta P over T and say that this delta P is mv minus mu over T. And we can factorize the m, so we have v minus u over T. But we know that v equals u plus at, which means v minus u equals at, therefore T or A equals v minus u over T. So this v minus u over T can be substituted with acceleration, so this becomes ma. So F equals ma. So we can derive an equation for force equals mass times acceleration, which was this first equation, using the equation for the change in momentum. So force is mass times acceleration, or force is change in momentum over time. And this is just the other equation, linear equations. Equations for linear motion. It's different, a linear equation and an equation for linear motion. So again, v is the final velocity, initial velocity, acceleration, and the distance traveled. And thus the equation for distance equals initial velocity times time plus half of the product of t squared and acceleration. Then GPE, which is gravitational potential energy, is mgh, where m is the mass, g is gravity or acceleration due to gravity, and h is the height that has been scaled by the object whose potential energy we are calculating. Then K equals half mv squared, which is this one here, which is kinetic energy. And kinetic energy is half times the mass times velocity squared. Then we have P equals E over T, which basically is power, is the rate at which energy is used, rate at which energy changes from one form to another. From one form to another, right? So again, for this equation, P can also be W over T, because E and W both forms can both be measured in terms of energy, because basically work is done when energy changes from one form to another, or when energy is changed from one form to another, work is done. So work and energy are equivalent in this case. So P can also be W over T. Then the last one, don't think there's any more. I think that's the last one. So the last one is weight equals mg. So weight equals, which is this W and this W are different, because that's weight and that is energy. So weight equals mg, which is just mass times gravity, or acceleration due to gravity, which in most cases is approximately equal to 10 meters per second squared. And in some cases, you're given 9.81 meters per second squared. So note how I've written 10 meters per second squared with a -2, or 10 meters / second squared without a minus. Okay, so those are the two ways you can express acceleration in meters per second squared. Okay, so any questions, let me know. I will make a video specific to the question, which is the best way of making videos, because you're doing a video for a specific person, and it might also help a lot of other people. But I'm repeating most of these because I think that some people will understand it in a different way depending on how I've presented it in a particular video. So not all videos are the same. So this is what I'm trying to do with these videos. So I'll see you in the next video.